In this second video on subtracting polynomials, I want to cover some more complicated problems. And the way you make these kind of problems more complicated is that you add more terms and you add more negative terms. So we can see in this example problem how we have 3 terms in the first polynomial, 3 terms in the second polynomial, and we've got a couple of negatives in this second part. Negatives in the first part also make it more complicated. But handling the negatives in the second part is the trickier aspect of it. I'm going to rewrite the first polynomial to demonstrate a technique for applying that negative that may be helpful to you. What you can think about is that we're circling each one of these terms along with the sign that's in front of it. So we have a negative x squared, we have a positive 2x, and we have a negative 3. Now, we can think of applying this subtraction sign into each one of these circles. So then we look at the number of subtraction signs or negative signs that we have, and we figure out whether this term is going to be negative or positive. X squared, 2 negatives, that makes for a positive x squared because the negatives cancel each other out. For the 2x, we have 1 negative and 1 positive. We know that that leaves us with a negative. Finally, negative 3, or 3, has 2 negatives. That leaves us with a positive. So that's what we would end up with. There's the 6 terms that we would then have to try to combine as we can. I'm not going to go through the solution to that one because I have 2 more examples coming up. I just wanted to demonstrate that technique. I'm going to demonstrate it again on these 2 problems. So the first problem here, once again, we have 3 terms in each part. Let me rewrite that first polynomial. 5x squared plus 2x. We're just dropping the parentheses. And then we move on to this next one. I'm not going to draw the circles, but I am going to draw a negative sign above each one of them, kind of in between the number and the sign. So 2 negatives in front of the x squared makes that plus x squared. 2 negatives in front of the 2x make that plus 2x. Those cancel. And in front of the 3, we have a negative and a positive, and we know that that leaves us with a negative. Now we can go ahead and identify our like terms. We have 5x squared and x squared. We have 2x and we have 2x. We have plus 2 as a constant, and we have minus 3. We have 3 pairs that we need to combine. 5x squared plus 1x squared gives us 6x squared. 2x and 2x, that's 4x, 2 plus 2. And plus 2 and minus 3, that's going to leave us with minus 1. And that would be the answer for problem 1. Now, if you didn't quite follow along with that, feel free to pause the video, try to work that out on your own. Make sure you get that same answer. Go back and rewatch my solution if need be. In the meantime, I'm going to move on to problem 2 and try to apply that same approach. I'm going to write this negative sign over the top of 3x squared, over the top of plus 8x, and over the top of minus 5. That's going to help me figure out those signs when I rewrite it. We write the first part, 3x squared plus 8x plus 6. Then we move on, and we have minus 3x squared. Because 3x squared was positive, we end up making that a negative. Negative over plus 8x, same thing. That leaves us with minus 8x. And then minus and minus, That's going to turn into plus 5. So the one thing we have to consider is that in front of that 3x, there's kind of a missing plus sign because that's a positive number. Now let's see what happens. This is sort of an unusual problem, but I wanted to go through an example like this. Here's our like terms, 3x squared minus 3x squared plus 8x. That's an x term. Here's another x term, minus 8x plus 6 and plus 5 are the constants. So let's combine those. I'm going to draw some lines here when I combine these, just to be clear what I'm combining. The 3x squared and the minus 3x squared. Well, those are just going to cancel each other out. 3 minus 3 is 0, but we're not going to write 0x squared. I will, actually I will, but that won't be part of our final answer. 8x and minus 8x, well, guess what? That does the same thing. 8 minus 8 is 0x. And then finally, we have plus 6 and plus 5. That's going to give us 11. But because these other two are zeros, we're going to leave them out of our final answer. And this whole thing simplifies to just the number 11. Sometimes that will happen. I wanted to go through an example to show you that that's not wrong. Sometimes the terms cancel and leave you with a very simple answer. So good luck on the 10 problems. If you have some trouble, repeat the process and try to do it again.